In this video we're looking at triangle sums. So let's start with interior angles. The angles inside a closed figure with straight lines. So here I have a triangle ABC. I've got 3 vertices and I have 3 interior angles. Exterior angle. The angle formed by one side of a polygon and the extension of the adjacent side. So there are 2 sets of exterior angles for each triangle. So I'm going to show one exterior angle here on triangle ABC. It's the extension of a side and the adjacent side. And then here with this orange and green triangle, I'll show you the 2 different sets of exterior angles that we get. One drawing it clockwise and one drawing them counterclockwise. Still the same triangle. Okay, remote interior angles. The 2 angles in a triangle that are not adjacent to the indicated exterior angle. So let me draw a triangle here ABC and extend one side. So we see angle A and angle B are remote interior angles to angle ACD. Triangle sum theorem. The interior angles of a triangle add up to 180 degrees. So if I have a triangle AMT and A is 27 and M is 82, I can solve for angle T by adding M and A together and subtracting it to both sides. And I get 71 degrees for angle T. So in this GeoGebra animation, we have triangle ABC. And this slider allows us to move the 3 angles so they share the same vertex, and we can see that the 3 end up being supplementary. So again, I can move any one of these points and we can see no matter what I do, the 3 are going to add up to be 180 degrees. Back to our note sheet, we've got exterior angle theorem. So if we take the sum of the remote interior angles, it would be equal to the non-adjacent exterior angle. So let's look at another GeoGebra construction. Here we have the sum of the interior angles, but also the exterior angle, which is the sum of the 2 remote interior angles, which in this case are angles A and B. So A is 71 and angle B is 66, and the exterior angle is the sum of these, which in this case is 137. But I can change this and we can see this relationship holds true. Okay, back to the notes. Let me just make a little drawing here showing that the exterior angle is the sum of the 2 remote interior angles. Okay, so let's take a look at example 1. We're looking for the measure of angle C and the measure of angle J. And we know that the measure of angle A plus B plus C equals 180. So we can solve for the measure of angle C. But we see that angle A and angle C are congruent, and angle B and angle I are congruent. So that must mean that angle C and angle J are also congruent. This is called the third angle theorem, which states if 2 angles in one triangle are congruent to 2 angles in another triangle, then the third pair of angles must also be congruent. Note, this doesn't mean that the triangles are congruent, but that they are similar. Example 2, find the value of x and the measure of each angle. Okay, so back to the exterior angle idea, that the exterior angle is equal to the 2 remote interior angles. So I'll set up these expressions. 4x plus 2 plus 2x minus 9, which is the sum of the remote interior angles, equals 5x plus 13. I solve, and I get x equals 20. Then I can substitute 20 in for x for each expression, and I get 82 degrees and 31 for the two remote interior, and 113 for the exterior angle. And if I add those together, the solution checks. So I hope this all makes sense.